Hey, what is up guys? Today we're back with another LeetCode video. We're going to be doing problem number 1585. Check if string is transformable with substring sort operations. So we're given two strings s and t. You want to transform string s into string t using the following operation any number of times. Choose a non-empty substring in s and sort it in place so the characters are in ascending order. For example, applying the operation on the underlying substring in 14, 2, 3, 4 results in 12, 3, 4, 4. Okay. So we sort that part and then it gets there. Okay, so return true if it is possible to transform string s into string t, otherwise return false. A substring is a contiguous sequence of characters within a string. Okay, so we have this first example. We have 84532, 84532, and that will turn into, we want to turn into 34852. And the way we can do that is first we will split up, we will transform 5 and 3, and then we transform 3, 4, and 8. Okay, so if you guys already took a look at this problem and tried some examples, the first thing you're going to notice is you don't really need to actually do the transformation. You just want to check if it's possible. So that's a mistake I made. This problem took me a long time. As you guys probably know by now, I'm not the brightest. These problems do take me a while. I can't solve them as quickly as some of the other guys. This problem took me like 2 hours to solve. But, so the first thing I was doing was I was trying to actually find the answer. And I was trying to do the transformations, and that led to a lot of problems. And I realized after a certain while, that's super hard. That's really, really hard to actually do the transformations. And I was also trying to find the minimum number of transformations. So we'll talk about that in a bit. So, the first thing you have to realize is you don't really need to do all the transformations. You just want to check if it's possible. So let's just keep that in track. You don't actually want to do the transformations, right? You don't actually want to do the sorting and everything. Now, the next thing you want to keep in mind is that you don't really need to sort an entire substring at once. You're not trying to find the minimum number of transformations to get from here to here. That's not what it's looking for. It's looking for just whether it's possible or not. So you can take as many steps along the way as you need to. So that's one thing you can notice. So let's say we were trying to find the cost. We wouldn't be looking for the minimum number of transformations. Or we're not actually looking for the minimum number of transformations. That's another thing to keep in mind. What do I mean by that? Well, if you look at this answer, right, this example they gave you, or let's just actually look at this example. So we have 3, 4, 2, 5, 2, 1 is when to take it to here. So the first step, you have to sort this entire substring. And we want to get it to this, right? So we will sort that the sequence of 4 all by itself, all together to get to this. But instead of sorting all together, what we can do is we can do it in very tiny little steps. Because when you try to do the whole entire sort all together, it gets very difficult and it gets very confusing. So you'll see we have 3, 4, 5, 2, 1, and we'll get to 2, 3, 4, 5, 1, right? The problem when we do this entire sorting all together is we don't know if it's correct or if it's not, or whether we need to sort the entire thing like this, or just this much, or just this much, or just this much, where we need to sort. So what we can do instead to get that to this is we can do just sort the 2 and the 5 in place. So we see 2 and 5, we could have sorted this to get into 2 and 5, and then this 2 and 4, and then 2 and 3. So we can kind of bubble the number back. That's another thing to keep in mind. We can bubble the number backwards. So that way it can maintain the relative ordering of the other characters in the string. That's one thing we can keep in mind. So first point is we don't actually want to do the transformations. The second observation you want to make is, let's say we're trying to find the transformations, we want to be looking for the minimum. So we can just bubble the number backwards, right? We can kind of bubble the number backwards. That's another observation we can make to maintain the relative ordering. Let's write that down too. To maintain relative ordering. Okay. Now let's say we bubble this number backwards to its proper place. We're just ignoring t for now. Let's say we're looking at 6 and we're just hypothetically just bubbling numbers backwards. What we're trying to do now is you want to bubble these numbers backwards to its original place. And so once these numbers get bubbled backwards to its original place, then we know that is sorted. And then now all we need to do is figure out how to transform 3, 4, 5, 1 into its proper 4 characters, whatever they would be, those 4 characters. And then we just keep kind of pushing forwards. So the way we're gonna think of this is we're kind of bubbling the numbers backwards while iterating through the target string. So what do I mean by that? So we have this target string 2, 3, 4, 1, 5, and we had this. Let's actually do this example 3, 4, 8, 5, 2, and we have this starting, which is A, 4, 5, 3, 2. So the way we're going to look at this is like this. So we see now this is our target string, and we know the 3 needs to be first. So I'm going to look for 3 here. Where is 3? Okay, I found my 3. Now I need to get that all the way to the beginning. How am I going to get that all the way to the beginning? We're going to use this bubbling approach that we just talked about. So one way, which you can think of originally, right? The first thought that might come into your head is, well, let's just sort between 3, 4, 5, and 8, and that way 3 will come in the beginning. Instead of thinking that way, you're gonna notice if you went down that approach, it's going to cause a lot of issues, and it becomes really complex. Instead, what we can do is maintain the relative ordering and do this kind of bubbling operation where we move 3 backwards at each moment. At some point, we can no longer move 3 backwards, right? We can no longer move this 3, back to its starting point, which is at index 0, right? And when can we no longer bubble backwards? Well, when 3 has a number before it that is smaller than it. So let's say it was like 8, 2, 4, 5, 3, 2. And we know this 3 needs to be in the starting position. That would be impossible. This 3 in the target array would be at index 0. That would be impossible. Why? Because now let's say we keep doing this bubbling backwards. We will switch 3 and 5. Then we'll switch 3 and 4. Now we have 2 and 3. I can't move this 3 behind the 2 through any sort operation. So it's false, it's impossible, and that's no longer, we can return false once we realize that, right? So that's how you want to look at this problem. So we're going to look at T. I'm going to look at this 3 over here, and I'm going to see, can I move this 3 back to the front by bubbling backwards? And how can I bubble backwards? Well, when every number before it is greater than it. So 5 is greater, 4 is greater, 8 is greater, that can move backwards. But not just every number that's before it, because sometimes a number can be before it, but it'll still work. Every number before it that isn't part of the final string yet. What do I mean by that? You'll see right now in this example what I mean by that. So let's just go through this. Let me keep this there actually. We have 8, 4, 5, 3, 2. And our target, let's just keep it above it, 3, 4, 8, 5, 2. Let's bubble this 3 backwards to the beginning. So 3 and 5, let's switch. 3 and 4, let's switch. 3 and 8, let's switch. Bang, right? 3 and 8 switched. Now we know the 3 is in the right place, and we know 3 has already been accounted for. So now we can kind of drop 3 from what we're looking at and just think of it as we're looking at this now. This new string and this new target. Right? That's what we're looking at now. So now let's go again, 8. We want the 8, oh sorry, this is a target, 4. We want 4 to be in the beginning. So let's look for it in the starting. So remember, this is target, this is starting. So I'm going to look for 4 again over here. 4 here, no. 4 here, yes. Let's try to move 4 back to the beginning. So we'll bubble that up 4. We'll bubble 4 to the beginning. So 4, 8 will switch. Because once you sort them, 4 will become before 8. And there you go. 4 and 4 are in the right place. And now we can cut this off. And then we can cut this off. Once again, let's go back to target. We're going to look for the 8. Oh, we see the 8 is already there. Great. We can cut this off. Cut this off. We'll do the same for the 5. We'll see the 5 is there. 5 is there. Great. Cut it off. Cut it off. 2 is there. 2 is there. Great. Cut it off. Cut it off. And there you go. That's our final solution. So that's how you want to look at the problem. It's kind of a bubbling backwards approach. And we want to make sure the numbers that are smaller than it. So we can bubble the number backwards to maintain relative ordering. And therefore, and make sure we cut off the number that we saw. Because for example, if we didn't do that, right, if we just had 8, 4, 5, 3, 2, if we weren't doing that cutting off and we're still applying rule number 3, 3, 4, 8, 5, 2, you'll see what the problem is. So let's do that. You'll see, yeah. Oops, I mixed it up. Okay, so we have 3 here. 3 will bubble to the beginning. So 3 will kind of just bubble down. So over here, we'll see that. Then we'll look at the 8s. And then the 8 needs to get to, and then we look at the 4 needs to get there, so the 4 and the 8 will switch. Then we're going to look at the 8 is in its right place, then we look at the 5, and then we're going to try to see if any number before it is greater than it. And over here, we'll see that the 3 is not, and the 4 is not, and therefore I can't reach it, we'll kind of return false. But we want to remind ourselves that we really accounted for 3 and 4, they're in the right place. So we're not going to check all the numbers before 5 that are greater than it. We're not going to check if all the numbers before 5 are greater than it. We're just going to check if all the numbers before 5 that are not part of our answer yet, that haven't reached the target yet, messes up again, right, aren't in this right place. So that's kind of what I mean by we want to make sure we keep cutting off. So that's the general approach. Now how are we going to write that down in code and make it as fast as possible? Well, every time we're looking back, right, because we have this look back operation where we look at the number we're currently at and everything before it that hasn't been cut off, so like this 3 and 4. So from 5, you have to look at all the numbers before it. In this case, just 1, but usually sometimes it might be a little longer. So we don't want to keep iterating backwards and looking at all the numbers we saw already. Instead, what we can do is we can iterate through it once originally, keep track of the indices, right? Keep track of the indices and keep track of how many of those numbers that we saw already. Because the only numbers are from 1 through 10, and we can make an array, and then we can keep track of all the indices that are at 0, that have the number 0, and then the number 1s, all the indices that have the number 1, and then all the indices that have the number 2 in their relative ordering. So that way, when I'm checking any number that's less than 5, that's before it, I can do that in constant time. Because I'll keep track of the 3 that we saw, and let's say there's another 3 over here. Let's just say there was another 3 over there in the target array. So when I see this 5, I'm gonna look at all the 0s and the 1s and the 2s and the 3s and the 4s, everything before 5. And for each of them, the 0, 1, 2, 3, and 4, I'm gonna know how many 0s I saw previously, how many 1s I saw previously, how many 2s I saw previously, as I was going through my target array, because we're gonna keep track of that. And so now I know I saw 1, 3 before. At 5, I already saw 1, 3 before. So now I know I can, in my array that's going to store all my indices, I know I can skip the first one because I already saw that first one. And so the first one will be at index 0, and the second one, I just need to check the second one, right? And so I'll see that it's at index whatever, 5, 6, I don't know, whatever that's there. And I'll see that it's past my 5, so that means it's good to go, right? That means it's good to go because this 3 is already counted for, it's kind of cut off already. We already visited, and you'll see what that means that exactly in code. I know it's a little confusing, but once we get to the code and once you kind of read through it a little bit, look at it a couple times, it'll just click in your head. So that's the solution, and we'll go through the code in 1 second right now. So we're back now with the solution. This came from Trubeck. He's the #1 answer in the discussion board. I kind of just modified his answer a little bit. I didn't really modify, I just changed variable names. Anyways. So remember now we talked about the indices of each of the characters in S, and so this is that array list that's going to keep track of that, and this will keep track of how many times we saw a digit in T so far, because we're going to be iterating through T and kind of sorting S, each digit in S, so it looks like T. So we're going to go through 1 through 9, and we're going to create an array list. Then we're going to fill these lists up. So we're going to go through S. And then we're going to keep adding the indices of that. So we're going to grab the, let's say for 0, we're going to fill up 0. So let's say 0 is at index 4, 5, and 7. So for 0, it's going to have the array list at index 0 will have 4, 5, and 7. So that's that. I think this is pretty simple to explain. This is the crux of the algorithm. And then over here is actually the real crux of the algorithm. But now let's kind of go through it. So let's just do an example, and it'll help a lot. So we're really sorry something cut off. I hope I didn't skip too much. I forgot where I was. But anyways, So we're going to go through t. We're going to grab the current digit at t. So let's say we're going through 8, 4, 5, 3, 2. Let's walk through the example. And then we're going to get the count of the current digit in s. And what that's going to be, this is going to be the current digit, the amount of the number of indices we saw, and then the size of that will be just the count of the current digit in s. And the first thing we're going to do is check if the number of times we saw the current digit in t so far is less than the number of times we saw the count of current digit in s. So if it's greater than or equal to it, then we have to return false, because that means the number of times we saw s and t do not equal. And the reason we're checking equal is because this will be one less, because we haven't done the increment yet. So that's that. This is just making sure the amount of digits of the amount of times we saw each digit in s is equal to the amount of times we saw each digit in t. Then here, what we're going to do now is we're going to go through all the numbers that are less than the current digit. So let's say we're at, I think this will help explain it a little bit. So let's say we're at 3, we're at this step. Remember, we're doing the bubbling, right? So let's just try to imagine the bubbling. This 3 will bubble all the way backwards to here, and this 8 will bubble in its proper place, and the 4 is already, so then the 8 and the 4 will bubble back over here. Then we did 3, 4, then the 8 will be in its right place, and we get to 5. So now we need to check 5. And just keep in mind, at each step, the counts are going to go up. I'll explain what the counts are in a bit, but the count for 3 will basically be 1, and 4 will be 1, and 8 will be 1, and then for 5 it'll be 0 so far, because we haven't seen a 5 yet, and for 2 it'll be 0. So the counts, if you can probably tell, are just the number of times we saw t so far. That's what this is, count of t so far, current digit. Okay, now so now we're at 5. Let's just say we're at 5. We're going through t. We hit 5. Now we hit 5. Now we're going to go through all the numbers less than 5. We're going to go for 0, 1, 2, 3, and 4. Okay. Now we're going to first check. Is it possible to see the 0 before the 5? Is it possible to see the 0 before 5? And so what that's going to be is we're going to see the number of times we saw this 0 in t. And we're going to check if that's less than the number of zeros in the actual string. Right? So over here we see 0. How many times is 0 in the actual string? Well, 0 is 0 times, so that's already going to be false. So this is going to be false, sorry. Yeah, so 0 is going to be false. So this will end up being false. So this return false, true, 1. Same thing for 1. And then when we hit 2, we'll see over here. So how many times did we see 2 so far in the target? And then count of t, it'll be 0 times, because we're just at 5 so far. We're just at 5. And then we're going to check how many times is it in s. It's 1, so this will return true. And so then this will check. And so now what this is going to check is it's going to make sure this 2 comes after the 5. It's going to make sure this 2 comes after the 5. Because if this 2 came before the 5 in our current string, what's our current string so far? We're at 3, 4, 8, 5, 2. Yeah, this is the current string so far, s. If this 2 came before the 5, there's no way to flip this 5 and 2 so the 5 comes after the 2, because we can only sort, right? So that's what this is doing. It's going to see, what is this doing right here? This is checking the next occurrence of 2. The next occurrence of 2 is less than the occurrence of the 5 right now. How does that work? Well, we're keeping track of how many times we saw the 2 so far, right? And so we saw 2 0 times so far. And so now I know in my indices array for 2, I know I skip only 0 2s. So now I don't skip any 2s. I just go straight to the first 2. I go straight to the first 2 and I look at that index. What is that index? If that index, right here, it's at index 5. This 2 is at index 5. If that index was, let's say, at index 3, then, or index 2 or index 1, I would have to return false. Because that means that 2 was before the 5, and there's no way to flip it around to get to the proper answer. So, that's what this is doing. It's going to grab the index of the next 2, and this is going to be the index of the 5, right? And if this one, 2 is less than the index of 2 is less than the index of 5, it's going to return false. How does that work? Well, we're going to get the number of times we saw the 2 so far, right? And we're going to see, we're going to get the index for that, and that's what this is doing. It's going to get the index for that. And then we're going to see the same thing for the 5. How many times do we see the 5 so far? And it's going to get the index for that. And we're going to make sure that this 2 is before that 5. And then it's going to return false. And then we're going to increment the number of times we saw it in T so far. Because let's say there was another 2 somewhere. Let's say there was this 2 right here. Right? This is our current string so far, and our target is also similar. Target is 3, 2, 4, 8, 5, 2. And now we're going to go to this 5. And now when I get to this 5, I'll have known that I already saw 2 so far once, right? Because we're going to keep track of this. That whole algorithm is running through, right? When we get to the 5, we see we already saw 2 so far. And so now I'm going to get count in T so far of the number less than current, which is the count of T so far of 2, is going to be 1, right? It's going to be 1. We see right here, it's going to be 1. So then when I get my indices in S of this number, I'm not going to get the 0th, I'm not going to get the first 2, I'm going to look at the second 2, right? I'm going to be skipping 1. So my indices so far for 2 is going to look like, what's this, 0, 1, and it's 2, 3, 4, 5, right? It's going to look like that. So I'm not going to look at this 1 right over here. I'm going to look at the 1 right at 5. So I'm going to check if my next occurrence of 2, which is the 5, which is index 5, is it less than my index of the number 5 is very, very confusing, which is at 4 right now, right? The 5 is at index 4. So is the 5 less than the 4? No, it's not. So we're great. We're good to go. And return false. And that's why we need to increment the number of times we saw T in so far. Because remember we were talking about the cutting off? This is basically doing that cutting off. We only need to check, we don't want to check all the number of 2's before, occurrences of 2 beforehand. We just want to check the next 2 and make sure it's not before it. Because everything before it, all the 2's that were earlier are already put in the right place. They're already cut off. I hope that really makes sense. And so that's really the crux of the algorithm. You can kind of just look through it once or twice. I saw the solution, and I didn't get it. I'll be honest, I did not get it. And I still worked on it I tried for a very long time, but I still wasn't able to get it. And when I saw the solution, I still had to look at it a couple of times just to make sure, oh, this is the way it works. I hope you guys enjoyed. I hope this helped. Please don't forget to subscribe and like, and let me know how I can improve these explanations, whether you guys want to see diagrams, graphs, I don't know, or if this works. Thank you guys.